Unknown location. Henderson Field, Guadalcanal, 2200 hours. Amidst the suffocating heat and thick blackness of the Solomon Islands, Private Robert Young Deere of the 164th Infantry Regiment crouches low beside his foxhole. He runs his thumb across the smooth walnut stock of his M1 Garand, ensuring for the last time that the rifle's action cycles cleanly. Only 11 days earlier, on October 13, 1942, his regiment had come ashore, marking the first time U.S. Army troops, not Marines, took part in offensive operations against Japanese forces in the Pacific. Now, shoulder to shoulder, with battle-worn Marines still equipped with bolt-action Springfield rifles, the men of the 164th wait, each M1 loaded with an 8-round en-bloc clip. The jungle hums with life, mosquitoes, cicadas, frogs, until, through the humid night, a new sound swells and then erupts. The chilling, unified roar of Japanese infantry charging headlong through the darkness, shouting "Banzai" and "Totsugeki" as they advance. At the front of that onrushing wave moves Lieutenant Kenji Yamamoto, platoon leader from the 29th Infantry Regiment. He struggles to maneuver his Type 38 Arisaka, a rifle whose long 31.4-inch barrel catches in vines and branches at every step. The weapon's 5-round internal magazine, fed with 6.5 by 50 mm Arisaka cartridges, forces him to work the bolt manually, up, back, forward, down, after every shot. Some of his younger soldiers carry the newer Type 99, chambered for the 7.7 by 58 mm round, but despite its heavier punch, it remains a bolt-action rifle limited to the same 5-round capacity, reloaded with stripper clips. What followed over the next 12 hours of relentless combat at Henderson Field would illustrate a truth that echoed throughout the Pacific War. The United States possessed a dramatic superiority in small arms firepower, an advantage that the Imperial Japanese Army had gravely underestimated. The clash revealed not just a contest of courage, but a confrontation between two eras of weapon design. The semi-automatic M1 Garand, with its rapid cycling mechanism and greater ammunition capacity, gave American infantrymen a sustained rate of fire that their opponents, armed with older bolt-action rifles, simply could not match. This technological gap magnified itself across every island campaign, from the steaming jungles of New Guinea to the ash-covered ridges of Iwo Jima, playing a decisive role in the outcome of the Pacific theater. While Japanese soldiers exhibited extraordinary bravery and an unyielding will to fight, they were equipped with rifles conceived in an earlier generation, weapons whose slower firing rate and smaller magazines left them at a critical disadvantage when facing American troops armed with Garands. The origin of that advantage traced back to John Cantius Garand, a Canadian-born engineer who joined the Springfield Armory in 1919. Over 17 years of experimentation and redesign, Garand developed a mechanism that harnessed gas from each fired round to cycle the bolt automatically, drastically increasing the soldier's rate of fire without sacrificing reliability. On January 9, 1936, the U.S. Army officially adopted his invention, making the United States the first nation in the world to issue a semi-automatic rifle as standard infantry equipment. The M1 fired the powerful .3006 Springfield cartridge, its 150-grain M2 ball projectile leaving the 24-inch barrel at roughly 2,850 feet per second, producing over 2,600 foot-pounds of muzzle energy. This combination of power, precision, and speed transformed the infantryman's role on the battlefield. Garand's gas-operated rotating bolt design became a symbol of American industrial ingenuity and a tangible demonstration of how engineering and mass production could could determine the fate of soldiers and nations alike in the world's first truly modern mechanized war. A small portion of the propellant gases was diverted from a mussel-side port to power a piston and operating rod, which in turn drove the rifle's bolt assembly without any manual cycling by the shooter. Pulling the trigger discharged a single cartridge. The gas system then opened the action, expelled the spent casing, and fed the next round into the chamber automatically. Under combat-trained hands, this mechanism permitted a well-practiced infantryman to deliver a steady volume of aimed fire, roughly 40 to 50 aimed shots per minute, compared with the 15 to 20 rounds per minute typically attainable with a manually operated bolt-action rifle. Reloading the M1 was likewise faster. Its fixed receiver accepted an 8-round en-bloc clip from above, and an experienced rifleman could replace an empty clip in under 3 seconds, returning the weapon immediately to full combat readiness. The rifle's development was not straightforward. Early experimental versions employed a primer-actuated firing system that proved unreliable and was abandoned. John C. Garand's design had originally been intended to use the new .276 Pedersen cartridge, but in 1932, General Douglas MacArthur directed a change. He required the Army retain the existing .3006 Springfield round so that current ammunition stocks could be used. That mandate slowed the production schedule, yet it ultimately worked to the rifle's advantage. The full-power .3006 offered excellent long-range performance and terminal effect when paired with Garand's action. Japanese service rifles evolved from an older lineage. The Arisaka family traced its ancestry to Colonel Narakira Arisaka's Type 30 design of 1897, which was developed to replace earlier unsatisfactory infantry arms. By the Second World War, the Imperial Japanese Army primarily issued 2 models, the Type 38, adopted in 1905, and the later Type 99, introduced in 1939, the 2599th year of the traditional Japanese calendar. The Type 38 fired the 6.5 by 50 mm semi-rimmed cartridge, a 139-grain projectile launched at about 2,500 feet per second, producing roughly 1,650 foot-pounds of muzzle energy. The Type 99 used the larger 7.7 by 58 mm cartridge, propelling a 182-grain bullet at near 2,400 feet per second with muzzle energy on the order of 2,300 foot-pounds. Both Arisaka models were conventional bolt-action rifles with internal 5-round magazines recharged via stripper clips. The Type 38's exceptionally long 31.4-inch barrel contributed to its accurate long-range performance, but that same length made it unwieldy in dense jungle terrain where firefights usually occurred inside 100 yards. The Type 99's shorter 25.9-inch barrel improved handling in close country, but the newer model arrived too late and in insufficient numbers to supplant the older Type 38 throughout the conflict. Mechanically, the Arisaka action was notable for its strength and thoughtful safety features. Post-war tests showed the Arisaka's receiver and locking system to be extremely robust, in some tests outlasting contemporaries such as the American Springfield, British Lee Enfield, and German Mauser designs. The rifles incorporated a safety that could be applied quietly and a bolt design with a gas escape channel intended to protect the firer in the rare event of a cartridge rupture. Nevertheless, those engineering merits could not offset the operational handicap of manual bolt operation when massed semi-automatic fire became the dominant force multiplier on the mid-20th century battlefield.
Perhaps the most telling contrast between the two nations lay in industrial capacity. From 1936 through 1945, American industry turned out on the order of 5.4 million M1 Garand rifles. Springfield Armory alone produced about 3.5 million of those, while Winchester Repeating Arms Company manufactured 513,880. Later, firms such as International Harvester and Harrington Richardson also contributed to small arm production, including additional output during and after World War II into the Korean War era. At peak rates, Springfield's lines were churning out roughly 1,000 rifles per day by January 1944, and Winchester peaked at about 600 rifles per day. That extraordinary industrial output ensured that by mid-1943, the overwhelming majority of American infantrymen and Marines in the Pacific were equipped with the semi-automatic Garand rather than a bolt-action service rifle. In short, while Japanese small arms designs demonstrated admirable engineering in aspects of strength and safety, American advances in semi-automatic operation, combined with unmatched wartime mass production, produced a practical and decisive edge in sustained infantry firepower. During the early months of 1943, U.S. logistics intentionally prioritized combat formations when allocating new small arms. As a result, the Marine Corps received shipments of roughly 22,000 M1 Garands per month, even though many Marines had been initially resistant to replacing their older rifles. By the close of the 1942 fiscal year, Marine inventories contained 62,886 Garands in total, although a portion of that quantity had not yet been distributed to frontline units. Japanese small arms output followed a very different trajectory. Between 1905 and 1945, production of the Arisaka Type 38 is estimated at about 3 million examples, manufactured across several arsenals, including facilities later known as Koishiwa, Tokyo, Kokura, Nagoya, and the occupied Manchurian plant at Mukden. From 1939 through 1945, roughly 3.5 million Type 99 rifles were produced at 9 arsenals, some of which were located outside the Japanese home islands, for example, facilities in Manchukuo and Korea. Taken together, Japanese factories turned out in excess of 6 million service rifles, yet this aggregate total still fell short of the sustained production tempo required to fully re-equip every formation with the newer model. Consequently, by war's end, many rear echelon units, garrisons, and naval infantry still carried the older Type 38, creating logistical complications because 2 different calibers and supply chains had to be supported simultaneously. American manufacture emphasized consistent quality control throughout the conflict. Springfield Armory applied acceptance standards that rejected any rifle unable to produce a 5-inch group at 100 yards, and interchangeability of parts across different makers was enforced through tight specifications and gauging. The result was a field repairable weapon. A damaged Garand could normally be restored to service using salvaged components from another rifle, regardless of the original manufacturer. In 1942, the adoption of improved heat treating methods actually increased the strength of receivers relative to pre-war examples. Surface finishes and stock materials evolved for durability and availability rather than cost-cutting. Parkerizing largely replaced traditional bluing to better resist corrosion in tropical climates, and shortages of walnut led to the substitution of birch and other hardwoods without compromising basic function. Some late-war simplifications, for instance stamped trigger guards instead of machined ones, were incorporated only after testing validated their reliability. Japanese production quality declined markedly as wartime pressures and material shortages intensified. Early runs of the Type 99 displayed advanced features for their time: chrome-lined barrels, making them among the first service rifles so treated, folding anti-aircraft sight arms, dust covers to shield the action, and built-in wire monopods for stability. Finishes were carefully applied, and stocks were crafted from quality domestic hardwoods with precise inletting. By 1944 and thereafter, many of these refinements had been eliminated. Final production examples often show coarse machining, simplified fixed rear sights replacing complex ladder arrangements, wooden butt plates in lieu of metal, and poorly fitted lower-grade wood. chrome lining largely vanished as chromium became scarce, monopods and decorative imperial markings were crudely stamped or omitted entirely. In some last-ditch rifles, tool marks and unfinished metal surfaces are plainly visible.
Beyond production quantities and finish, the Garand semi-automatic operation produced tangible tactical benefits beyond a simple increase in rounds per minute. Because the action cycled automatically, a marksman retained his sight picture and cheek weld after each shot, enabling faster and more precise follow-up engagements. The gas-driven operating rod, tapped from a port near the muzzle, generated enough energy to cycle reliably under adverse battlefield conditions, tolerating fouling from mud, sand, volcanic ash, or heavy carbon buildup that would hamper less robust mechanisms. The M1's on-block 8-round clip system also enabled extremely rapid reloads. An experienced user could replace an empty clip in well under 3 seconds versus the 5 to 7 seconds typically required to feed a bolt-action rifle with stripper clips. While critics sometimes noted the characteristic metallic ping when an empty on-block was ejected, a sound said to announce to nearby opponents that the rifle was empty, the clip's ejection also served as an immediate, unambiguous tactile and audible indicator that the weapon required reloading, reducing the chance of confusion in the heat of battle. Taken together, these factors, focused allocation practices, stringent American quality control and interchangeability, and the operational advantages conferred by semi-automatic fire, combined with Japan's shrinking material base and declining manufacturing standards to produce a practical and sustained edge in infantry small arms effectiveness as the Pacific campaigns progressed. The M1 Garand, weighing approximately 9.5 pounds, was heavier than many modern rifles, yet this mass played a key role in mitigating the substantial recoil of the .30-06 Springfield cartridge. The rifle's weight distribution, concentrated between a solid walnut stock and a heavy barrel, contributed to stability during rapid aimed follow-up shots. Measuring 43.6 inches in total length, the weapon offered a balance of maneuverability and control, while its two-stage military trigger, though not a precision match-grade component, delivered reliable and consistent performance once mastered by trained infantrymen. By contrast, Japanese Arisaka rifles, despite their sturdy construction and theoretical accuracy at range, were constrained by the limitations of bolt-action operation. Each round fired required the shooter to manually manipulate the bolt through 4 distinct motions: raising the bolt handle, drawing it fully rearward to eject the spent casing, pushing it forward to chamber a fresh round, and finally rotating the handle downward to lock the action. Even in experienced hands, this sequence disrupted the shooter's cheek weld and sight alignment, taking 2 to 3 seconds to complete, time enough to affect survival in close-quarters engagements. The Type 38, with a total length of 50.3 inches, proved particularly unwieldy in jungle environments. Its excessive length caused frequent snags on vegetation, made target acquisition in dense undergrowth slow, and hindered use in trenches, bunkers, and fortified positions. Although the long barrel enhanced long-range accuracy and reduced bullet drop, the typical combat ranges in the Pacific rarely exceeded 100 yards, with many encounters occurring at mere conversational distance. The 5-round magazine compounded the problem, forcing Japanese soldiers to reload approximately 60% more often than an American infantryman using the M1 Garand. Loading via stripper clips required opening the bolt, seating the clip, pressing rounds into the magazine, withdrawing the clip, and closing the bolt, a process that normally took 5 to 7 seconds under ideal conditions and considerably longer under combat stress or awkward firing positions. The U.S. military benefited from a major logistical advantage due to the M1's use of the .3006 Springfield cartridge, which was already standard for rifles, machine guns, and automatic weapons, including the M1903 Springfield, M1917 Browning, M1919 Browning, and Browning automatic rifle, BAR. This commonality greatly simplified supply chains. A single ammunition type could sustain rifles, automatic rifles, and machine guns alike. The rimless cartridge design also promoted reliable feeding from clips, belts, and magazines. American ammunition production capacity was immense. By 1943, the Lake City Army Ammunition Plant alone could produce approximately 200 million rounds annually, supplemented by output from the Frankfurt Arsenal, Denver Ordnance Plant, and other facilities. Rigorous quality control ensured consistent ballistic performance, with M2 ball rounds maintaining velocity deviations of less than 40 feet per second between production lots. Japanese forces, however, faced a more complicated ammunition situation. Type 38 rifles required 6.5 by 50 mm semi-rimmed cartridges, while Type 99 rifles used the larger 7.7 by 58 mm round. The smaller 6.5 mm cartridge generated less recoil and allowed soldiers to carry more ammunition, but was underpowered against entrenched or covered targets. The 7.7 mm round corrected these deficiencies, but introduced a dual-caliber logistics problem which proved persistent and disruptive. Documented incidents include the 23rd Infantry Regiment on Guadalcanal, which received 7.7 mm rounds for Type 38 rifles, rendering both weapons and ammunition effectively unusable. Similar supply mismatches occurred in the Philippines and on isolated island garrisons. The semi-rim design of the 6.5 mm cartridge also occasionally caused feeding problems in tropical climates where corrosion degraded the rounds. When the 164th Infantry Regiment, a North Dakota National Guard unit, landed at Guadalcanal on October 13, 1942, they arrived equipped with M1 Garand rifles, a capability highly prized by Marines still armed with M1903 Springfield bolt-action rifles. The arrival of these semi-automatic weapons elicited both envy and cautious optimism among the Marines. During the decisive battle for Henderson Field on October 24–25, 1942, the tactical advantages of the M1 Garand became undeniable. Soldiers equipped with Garands were able to maintain continuous, accurate fire without breaking position, rapidly re-engaging targets, and effectively suppressing Japanese assaults. Staff Sergeant Mitchell Page, a Marine operating a machine gun alongside the 164th Infantry, directly observed the impact of this superior firepower, witnessing how semi-automatic rifles fundamentally altered the dynamics of infantry combat on Guadalcanal. Private First Class James Cass of Company M, 164th Infantry, later described the Japanese assaults as successive human waves that were almost invisible in the night except for flashes of bayonets. Cass recalled that the M1 Garand changed the character of the defense. A trooper could send 8 rounds downrange in rapid succession as the enemy closed 30 yards, each rifle functioning like a short-range automatic weapon. Because the Garand cycled on its own, soldiers did not have to manipulate bolts or break their cheek weld. They could press the trigger, watch the rifle reset, and press again, a rhythm of sustained aimed fire that continued until the clip emptied. Units of the 164th were inserted into the battle line in small increments as the Japanese attack unfolded, reinforcing Marine positions that were nearing collapse. Colonel Bryant Moore later recorded that his regiment expended in excess of 250,000 rounds of .306 ammunition during the 2-day engagement. Dead Japanese combatants accumulated before the 164th's positions in numbers that testified to the lethal effectiveness of rapid, well-placed Garand fire. Marine observers also noted the difference. Private Robert Lakey, author of Helmet for My Pillow, wrote about watching Army soldiers in action. At first, the Marines assumed the newcomers were inexperienced, but the continuous, overlapping report of the Garands proved otherwise. It was a volume and steadiness of fire unlike the intermittent crack of the older Springfields. From the Japanese perspective, survivors and post-war memoirs record the shock of confronting American semi-automatic rifles. Sergeant Masao Watanabe of the 29th Infantry Regiment, 2nd Division, Sendai, reflected in a memoir later recovered from military archives that officers had emphasized spirit and moral superiority over material disparities. He wrote that Japanese doctrine and practice, built around bolt-action rifles and the ferocity of close assaults, proved disastrously ill-suited against Americans who could deliver rapid, repeated aimed shots. Watanabe described charging into what felt like a wall of lead where the Japanese single-shot rhythm left them exposed while American troops fired multiple rounds in the same interval.
A letter found on Lieutenant Hiroshi Takahashi of the 230th Infantry Regiment offered a similar judgment. The American semi-automatic rifle, he observed, allowed an individual infantryman to deliver rates of fire comparable to the Japanese light machine gun, creating the auditory and lethal illusion that entire positions were defended by automatic weapons. Takahashi reported men falling before they could even cycle their bolts for a follow-up round. The performance of the Garand in other campaigns reinforced these assessments. At Cape Gloucester in December 1943, where Marines of the 1st Marine Division landed under relentless rain, Private First Class Eugene Sledge later wrote in With the Old Breed that the M1 was the most dependable item in his kit. In cascading rain, clinging mud, and sucking quagmire, the rifle continued to function when many other systems struggled. Similarly, accounts from Saipan's massive pre-dawn banzai attack on 7 July 1944 describe how infantrymen armed with Garands poured out a torrent of fire as waves of enemy troops closed. Private First Class Harold Agerholm of the 4th Marine Division and Corporal John Miller recalled the continuous staccato of semi-automatic fire and the steady ejection ping of empty clips, a grim, repetitive sound that marked both the tempo of defense and the enemy's inability to match sustained volume. On Peleliu in September 1944, where Japanese tactics shifted toward well-prepared defensive positions rather than mass charges, the semi-automatic rifle still dominated. Marines such as Corporal R.V. Bergen reported that small teams with Garands could saturate a cave entrance or bunker with dozens of rounds in the time it took defenders to fire a handful of shots in reply, suppressing defenders long enough for assault teams armed with flamethrowers and explosives to close and neutralize positions. These battlefield outcomes were not accidental, but flowed from doctrine and training built around the M1's strengths. American marksmanship programs at training centers nationwide, Fort Benning, Camp Perry, and other posts, concentrated on exploiting the Garand's semi-automatic capability without sacrificing accuracy. Qualification and tactical courses train soldiers to engage targets from ranges between 100 and 500 yards, emphasizing rapid, controlled fire and retention of the sight picture between shots. Army Field Manual TM-23-5, U.S. Rifle Caliber 30 M1, set achievable expectations for combat firing, directing men to sustain 40 to 50 aimed shots per minute in action. Troops were taught to observe impacts, correct, and re-engage quickly, a sequence made feasible by the rifle's automatic cycling and rapid reload with the 8-round in-block clip. Taken together, personal testimony from both sides, battlefield expenditure figures, and after-action accounts from disparate Pacific campaigns converge on a consistent conclusion. The widespread issue of the semi-automatic M1 Garand to U.S. infantry materially altered small unit combat. It allowed individual riflemen to deliver sustained, accurate fire that undermined massed infantry assaults and reshaped the tactical options available to both attackers and defenders across island battlefields. U.S. military training programs allocated ammunition liberally, ensuring that recruits and combat units alike had ample live-fire experience. Basic trainees fired at least 210 rounds during qualification courses, with additional allotments for advanced marksmanship and tactical drills. Units preparing for deployment often expended thousands of rounds per soldier in live-fire exercises, developing the muscle memory and confidence essential for survival under fire. Initially, the Marine Corps expressed caution about adopting the M1 Garand, concerned that high rates of fire might degrade discipline and marksmanship. Over time, however, Marine doctrine adapted, emphasizing controlled, rapid, aimed shots that leveraged the Garand's semi-automatic operation while retaining the precision and standards of traditional marksmanship.
Japanese marksmanship traditions, rooted in centuries of samurai discipline, stressed precision and deliberate fire, encapsulated in the principle of ichigeki atsu, one shot, one kill.
This philosophy reflected both spiritual ideals and the practical constraints of bolt-action rifles. Soldiers trained extensively at long range, particularly with the Type 38, whose exceptional barrel length and accuracy at distance were prized. Imperial Japanese training manuals underscored the primacy of spirit and courage over material considerations, instructing that the rifle and bayonet were extensions of the warrior's resolve rather than decisive tools of firepower. Daily drills in bayonet technique and controlled linear assault honed these skills, and the Type 38's length was theoretically advantageous in close combat. Yet the environments of the Pacific, dense jungle, limited visibility, and uneven terrain rarely permitted the long-range shots for which Japanese soldiers had trained. The banzai assaults that had succeeded against poorly equipped opponents, such as Chinese conscripts, proved catastrophic against U.S. troops armed with semi-automatic rifles. The sustained, rhythmic fire of Garands, accompanied by the distinctive metallic ping of ejected clips, became a psychological weapon, breaking morale before enemy forces could close with their intended objectives. Captured Japanese documents from 1943 warned that the sound of American semi-automatic fire resembled many machine guns firing, and counseled soldiers to maintain resolve, yet the theoretical advantage of spiritual superiority could not overcome overwhelming material firepower. Prisoner accounts illustrate the disjunction between doctrine and battlefield reality. Saipan captive Yukio Nakamura reported that Japanese officers had portrayed American soldiers as relying on machines rather than courage, yet in combat, their rifles fired without stopping, making close-quarters bayonet tactics impossible. Conversely, American troops gained confidence from their firepower edge. Marine Corporal James Russell described the M1 Garand's effect on morale. The ability to discharge 8 aimed rounds in rapid succession created a sense of invulnerability, allowing Marines to maintain composure during enemy charges and continue delivering suppressive fire until the threat was neutralized or the clip required replacement. At the squad level, the advantage of the semi-automatic rifle became decisive. A typical American rifle squad of 12 men armed with 10 M1 Garands and 2 Browning automatic rifles could sustain 400 to 500 aimed rounds per minute, while a similarly trained Japanese squad with Arisaka rifles could achieve only 150 to 180 rounds per minute, even with optimized bolt-action cycling. This disparity fundamentally reshaped small unit tactics. U.S. fire teams could lay down suppressive fire while maneuver elements advanced, keeping enemy heads down and enabling coordinated assaults. Japanese squads, constrained by manual bolt operation, struggled to generate sufficient suppressive fire while maintaining mobility. When scaled to company size, roughly 200 soldiers, the difference became overwhelming. American rifle companies could deliver concentrated defensive fire sufficient to halt massed attacks. During the October 24th to 25th, 1942 battle for Henderson Field, Companies G of the 164th Infantry demonstrated this advantage. Company G reported firing 30,000 rounds of 30-06 ammunition in a single night, averaging 150 rounds per man, while sustaining only light casualties. The volume of fire was mathematically insurmountable for attacking Japanese battalions. Even under conditions of darkness, confusion, and fear, a Japanese formation of 800 men faced a U.S. company capable of directing 8,000 aimed rounds per minute, creating kill zones where courage alone could not prevail. The superiority of the Garand had strategic implications. The ability to deliver sustained, accurate semi-automatic fire allowed American forces to establish and hold beachheads during amphibious operations, with fewer personnel enabling rapid reinforcement and breakout operations. Across the Pacific, from Tarawa, Guadalcanal, Otinuk, Saipan, Guam, Peleliu, Iwo Jima, and Okinawa, the pattern repeated. Japanese forces, unable to match American firepower, increasingly relied on desperate defensive measures. Even in fortified positions, the slower rate of fire from bolt-action rifles limited their capacity to exploit fleeting opportunities or respond effectively to U.S. assaults.
The persistence of bolt-action rifles in Japanese service stemmed in part from historical precedent. Victories in the Russo-Japanese War 1904 to 1905, achieved with Type 30 and Type 35 Arisaka rifles, reinforced confidence in traditional doctrine. Disciplined training, tactical innovation, and the supposed supremacy of warrior spirit had defeated Russian forces. However, this prior success fostered institutional blindness to technological evolution. By the Pacific War, adherence to outdated rifle technology left Japanese infantry unable to match the sustained firepower and tactical flexibility of American units equipped with the M1 Garand, rendering their spiritual and tactical doctrines insufficient against material realities. The Japanese officer corps, steeped in the legacy of the Russo-Japanese War, largely interpreted that conflict as the definitive proof of Japan's rise as a modern military power. This reverence for past triumphs obscured the recognition that industrialized warfare had fundamentally evolved. World War I had made clear that firepower, rather than individual bravery alone, would dominate the battlefield. Japan's limited participation in that war left its military slow to internalize these lessons. In contrast, the United States, shaped by its experience in Europe, embraced these insights. General John J. Pershing, commanding the American Expeditionary Force in 1918, had observed the decisive role of automatic weapons in trench combat and explicitly called for the development of a semi-automatic rifle, noting that the soldier capable of delivering the most precise and rapid fire would dominate future conflicts. This directive set in motion the development process that ultimately produced the M1 Garand. Over nearly 2 decades, the U.S. refined the Garand through iterative trials, extensive testing, and the creation of an industrial base capable of mass production. By the time the rifle was officially adopted in 1936, the United States had not only created a superior infantry weapon, but also established an integrated system for its manufacture, maintenance, and logistical support. Japan eventually recognized the theoretical advantages of semi-automatic rifles and initiated development in the 1930s, including Kojiro Nambu's Type K design and various gas-operated prototypes. However, these projects received limited attention and resources, with priority given to aircraft, naval vessels, and other programs deemed strategically vital. Even when Japanese engineers attempted to emulate the M1 with the Type 4 rifle, production was minimal. Only around 250 component sets were completed, resulting in roughly 100 to 125 assembled rifles before the war ended. The Type 4, chambered for the 7.7mm round and fed via a 10-round internal magazine loaded with 2 5-round stripper clips, demonstrated Japan's understanding of the Garand's advantages, but also highlighted its industrial incapacity to produce such weapons at scale. The comparative metrics of firepower underscored the American edge. The M1 Garand, firing M2 ball ammunition, generated 2,656 foot-pounds of muzzle energy. At a trained soldier's rate of 40 aimed rounds per minute, this translated to 106,240 foot-pounds per minute, barely 1/3 of the M1's output. While the 30-06 cartridge exhibited more bullet drop than the 6.5mm Arisaka at extreme distances, it excelled at the ranges typical of Pacific engagements. At 300 yards, the Garand's round descended approximately 13.5 inches while retaining 1,900 foot-pounds of energy, enough to penetrate multiple layers of vegetation and incapacitate enemy personnel. The 6.5mm Arisaka dropped only 11 inches, but retained just 1,100 foot-pounds, often insufficient to penetrate cover. U.S. ordnance testing at Aberdeen Proving Ground in 1940 quantified these advantages. Soldiers equipped with M1 Garands consistently fired 24 aimed rounds at 200 yards, achieving 90% accuracy on man-sized targets. Comparable units using M1903 Springfields, which functioned similarly to the Arisaka, managed only 10 aimed rounds per minute with 85% accuracy.
In rapid-fire simulations, M1-equipped troops could engage 3 targets in the time bolt-action soldiers engaged 1. Longer duration tests revealed that after 5 minutes of continuous firing, Garand operators maintained 80% of their initial rate of fire, while bolt-action users dropped to 60%, fatigued by the repetitive arm and shoulder movements required to cycle their rifles manually.
Combat records from the Pacific illustrate these disparities. On Guadalcanal, Army units carrying Garands averaged 100 to 200 rounds per soldier per day in intense engagements. Marines, still using Springfield rifles, fired 60 to 80 rounds per man under similar conditions, not because of waste, but due to the Garand's superior ability to deliver effective fire on fleeting targets. Japanese troops seldom exceeded 40 to 50 rounds per day, constrained both by limited supply and the mechanical pace of bolt-action operation. Captured reports frequently cited ammunition shortages, but even when cartridges were available, the slow cyclic rate hindered consumption. Over the course of the war, Japanese military documents increasingly acknowledged the American superior firepower. In November 1942, Lieutenant General Harukichi Yakutake, commanding the 17th Army on Guadalcanal, observed, "Enemy rifle fire possesses a density and accuracy beyond our expectations. Each adversary appears armed with an automatic weapon. Even when numerically superior, our forces cannot achieve fire superiority. Emphasize night operations and infiltration to mitigate the enemy's advantage." By 1944, Japanese doctrine had adapted to the stark reality of American material superiority, reflecting a reluctant acknowledgement that valor and discipline alone could not offset the technological and industrial gap. Instructions issued to the defenders of the Mariana Islands underscored the lethal effectiveness of American automatic weapons. Commanders cautioned, "Enemy rifles and machine guns produce a dense, continuous wall of fire in daylight. Offensive action must be restricted to nighttime or periods of adverse weather. Daylight movement will result in near-certain annihilation." Lieutenant General Tadamichi Kuribayashi, the innovative commander responsible for the defense of Iwo Jima, echoed this assessment in January 1945. "The semi-automatic rifles of American soldiers provide firepower equivalent to 3 or 4 of our infantrymen. Futile frontal charges are unacceptable. Our objective is to inflict maximum casualties while defending each meter of ground from fortified positions." Kuribayashi's adoption of defense in depth, avoiding massed banzai assaults, extended the duration of the battle but could not counterbalance the Americans' material advantage. In response to the overwhelming firepower of U.S. forces, the Japanese military attempted several measures to increase infantry lethality. One such effort was the Type 100 submachine gun, introduced in 1942, designed to deliver automatic fire at close ranges. However, production totaled only around 27,000 units by the end of the war, insufficient to influence large-scale engagements. The weapon fired the 8mm Nambu pistol cartridge, which offered limited range and stopping power, leaving Japanese troops underpowered in the context of Pacific combat. More significant was the Japanese attempt to directly replicate the M1 Garand. When American forces captured the Yokosuka Naval Arsenal in 1945, they discovered the Type 4 rifle, a reverse-engineered adaptation of captured Garands. The Japanese had modified the design to chamber 7.7mm ammunition and feed from a 10-round internal magazine loaded via standard 5-round stripper clips. Engineers incorporated additional improvements, such as a rubber recoil pad and a last-round bolt hold-open mechanism. Nevertheless, Japanese industry could not mass-produce this advanced rifle. While parts for approximately 250 rifles were manufactured, only 100 to 125 complete weapons were assembled before the war ended. The Type 4 program demonstrated that Japanese designers fully understood the advantages of semi-automatic fire, but were constrained by industrial limitations.
Beyond production shortfalls, cultural factors hindered adaptation. The Japanese military hierarchy maintained a strong emphasis on spiritual and moral qualities over material advantages. Colonel Masanobu Tsuji, a staff officer who served in multiple campaigns, reflected post-war. We recognized that American weapons were superior, but acknowledging this openly would have undermined morale. We had to sustain belief in spiritual supremacy, even as our troops were decimated by automatic fire. This mindset extended to training. Even in 1944, Japanese infantry preparation prioritized bayonet techniques, night infiltration, and spiritual conditioning over rifle proficiency. Official training manuals devoted merely 3 pages to rifle marksmanship, while 12 pages addressed spiritual readiness and hand-to-hand combat. This imbalance reflected deeply held convictions about the nature of warfare that could not easily be reconciled with technological realities. The Battle of Okinawa, fought from April through June 1945, ultimately tested the limits of Japanese determination against American material superiority. The contrast between disciplined, well-armed U.S. infantry and Japanese troops constrained by bolt-action rifles, limited automatic weapons, and culturally reinforced doctrines of spiritual primacy exemplified the culmination of a conflict increasingly dominated by industrialized firepower rather than individual heroism. On the threshold of the Japanese home islands, American forces numbering roughly 180,000 faced 120,000 Japanese defenders in what would become one of the most lethal engagements of the Pacific Campaign. Under Lieutenant General Mitsuru Ushijima, Japanese troops applied lessons from prior defeats. Rather than relying on massed banzai assaults, they constructed complex defensive networks among Okinawa's jagged hills and rocky terrain. Yet even in fortified positions, the inherent limitations of bolt-action Arisaka rifles significantly constrained Japanese firepower. When U.S. units advanced, defenders were seldom able to generate enough sustained fire to halt the assault. Private First Class Desmond Doss, the conscientious objector medic awarded the Medal of Honor, later recalled the protective effect of American semi-automatic rifles while he rescued wounded soldiers. He described the M1 Garands as producing an unbroken roar of fire, keeping enemy heads down as he moved through the battlefield. If every soldier had been armed with bolt-action rifles like the Japanese, I never could have saved those men, he reflected. On May 4, 1945, Japanese forces mounted their only major counterattack of the Okinawa campaign. Approximately 5,000 infantrymen launched a coordinated offensive aimed at breaching the American rear. The assault commenced at 0430 hours, preceded by the largest Japanese artillery barrage of the Pacific War. 12,000 shells fired in 30 minutes. As Japanese troops emerged to cross open ground, they encountered a relentless wall of American fire. Private First Class Martin Brennan of the 17th Infantry Regiment described the engagement. They advanced in organized waves supported by artillery, but our Garands never stopped firing. 8 rounds, ping, reload, 8 more. The noise was overwhelming. The Japanese could only manage 1 or 2 shots before our semi-automatic rifles cut them down. The attack ended in catastrophic Japanese losses, roughly 4,000 dead, compared to 714 American casualties. The concentration of automatic and semi-automatic fire, combined with supporting artillery, created lethal kill zones that courage alone could not overcome. Even in close-quarters combat, the M1 Garand provided a decisive advantage. Sergeant William Manchester, later a noted historian, observed during Okinawa that the ability to fire 8 rounds without cycling the bolt preserved lives. Japanese soldiers struggled under fire, fumbling with their bolt-action rifles, while American troops maintained uninterrupted volleys.
Preparations for Operation Downfall, the planned invasion of Japan, relied heavily on the Garand's effectiveness. Military planners used casualty data from Okinawa to calculate the level of firepower necessary to overcome anticipated resistance. Production schedules aimed to supply 500,000 replacement M1 rifles, with Springfield Armory and Winchester increasing output to 2,000 rifles daily by August 1945, while a third facility operated by International Harvester was scheduled to commence production. Ammunition requirements were equally massive, with projections of 100 million rounds of .30-aught sticks per month for rifle use alone. Intelligence assessments estimated Japanese home defense forces would include approximately 2.5 million Arisaka rifles in military units, supplemented by millions more for civilian militias. Many of these weapons were outdated, training rifles, or rudimentary single-shot models. Even the Type 99 rifles produced in 1945 were so poorly made that U.S. analysts questioned their reliability and safety. Planners envisioned a combination of naval gunfire, aerial bombardment, and Garand-equipped infantry providing the necessary suppressive fire to secure the beachheads. Analyses of prior Pacific engagements demonstrated that American troops armed with semi-automatic rifles incurred roughly 40% fewer casualties than would have been expected if equipped with bolt-action weapons under similar conditions. The Japanese, fully aware of their disadvantage, resorted to desperate measures. Plans included civilian conscripts as shields, close-quarters urban combat to neutralize the rate of fire advantage of semi-automatics, suicide swimmers with explosives, bamboo spears, and even rudimentary biological weapons. By 1945, the Arisaka rifle, once the centerpiece of Japanese infantry power, had become just one element in a last-ditch, increasingly improvised defensive strategy. Against overwhelming American industrial capacity, semi-automatic rifles, and artillery support, Japanese troops could no longer rely on courage and tradition to achieve battlefield success. The conclusion of World War II came with the atomic bombings of Hiroshima and Nagasaki, preventing the execution of Operation Downfall, the planned invasion of Japan. Post-war studies suggested that had the invasion proceeded, American casualties could have ranged from 500,000 to 1 million, while Japanese losses might have reached several million. Even with the M1 Garand's superior firepower, the human cost on both sides would have been staggering. The Garand's battlefield success left a lasting mark on small arms development across the globe. The Soviet Union, having encountered production limitations with the SVT-40 semi-automatic rifle during the war, created the SKS carbine, directly inspired by captured Garands. China's Type 56 carbine subsequently emerged as a derivative of the SKS. In Europe, France developed the MAS-49, integrating lessons from both the M1 Garand and their own pre-war semi-automatic projects. Even traditionally cautious Britain began post-war experiments with semi-automatic designs, reflecting a broader global acknowledgement of the advantages demonstrated by the Garand. Other notable examples included the Belgian FN-49, Swiss STW-57, and the Italian BM-59, all drawing upon the principles of semi-automatic efficiency, first proven in World War II. The M1 Garand remained in U.S. service throughout the Korean War, where it again outclassed the bolt-action rifles of Chinese and North Korean forces. During early engagements, American units armed with Garands and supported by automatic weapons repeatedly halted massive Hunan wave assaults, reminiscent of Japanese banzai tactics, underscoring the rifle's enduring tactical relevance. Gradually, the M1 was superseded by the M14 in the late 1950s and early 1960s.
In an intriguing post-war twist, the newly established Japanese self-defense forces were equipped with M1 Garands during the 1950s. Soldiers who had once faced this weapon in combat now trained with it firsthand, gaining a direct understanding of the firepower their predecessors had confronted. The JSDF ultimately received around 150,000 Garands through U.S. military assistance programs. Japanese veterans interviewed in the 1960s frequently credited American firepower, and particularly the Garand, as a decisive factor in their wartime defeats. Saburo Sakai, Japan's most renowned surviving fighter ace, commented, "We could match Americans in courage and tactics, but their rifles gave each soldier the firepower of 3 of our men." In the decades following the war, both American M1 Garands and Arisaka rifles became highly valued collector pieces, though for different reasons. The M1, widely distributed through the civilian marksmanship program, has sold over 500,000 surplus rifles in the United States, becoming one of the most recognizable and widely owned historic firearms. Its distinctive ejection ping is emblematic in popular culture, appearing in countless films, television series, and video games. The rifle's reputation as an exceptionally effective combat weapon remains, with figures like General George S. Patton lauding it as among the finest infantry implements of World War II. Even in modern marksmanship competitions, the Garand continues to demonstrate remarkable accuracy. Arisaka rifles, particularly examples retaining intact imperial chrysanthemum markings, are similarly prized. The chrysanthemum, a symbol of the Japanese emperor, was often deliberately removed from rifles prior to surrender, making surviving specimens rare and highly sought after by collectors. Both the M1 Garand and Arisaka rifles today served as tangible reminders of their respective military histories, representing the contrasting philosophies and technological approaches of the United States and Japan during the Pacific War. Modern ballistic testing has confirmed that the Arisaka action was remarkably robust, surpassing even the Mauser or Springfield in structural strength. Yet no amount of mechanical durability could offset the fundamental limitations inherent in bolt-action operation. Interestingly, both the M1 Garand and Arisaka rifles have seen combat in the 21st century. Garands supplied decades earlier have appeared in conflicts in the Middle East, while Arisakas have been documented among insurgent forces in Afghanistan and Myanmar, illustrating the longevity and resilience of their design, even as they became tactically obsolete. The effectiveness of semi-automatic fire was first dramatically demonstrated on October 24, 1942 at Henderson Field, where Private Robert Young Deere of the 164th Infantry Regiment and thousands of fellow American soldiers showcased the decisive advantage of the M1 Garand. They revealed a core principle of modern warfare: technological and industrial supremacy could determine the outcome of combat independently of individual courage or determination. In practical terms, the M1 Garand allowed trained soldiers to deliver 40 to 50 aimed shots per minute, in contrast to the Arisaka's 15 to 20. 8 rounds could be fired before reloading, versus the Arisaka's 5. Semi-automatic cycling replaced manual bolt manipulation, allowing uninterrupted sight alignment and rapid follow-up fire. Against charging Japanese forces, the sheer weight of continuous fire often stopped assaults before they could reach American lines. These differences, multiplied across countless engagements from Guadalcanal to Okinawa, had a decisive impact on the Pacific Campaign.
Lieutenant Kenji Yamamoto, who led a Type 38 Arisaka charge on that same October night, did not survive to witness the battle's conclusion. His rifle, noted for its precision, strong receiver, and smooth bolt operation, was powerless against the concentrated barrage of semi-automatic fire. Examination of his weapon after the engagement revealed 3 rounds remaining, while he had managed only 2 shots in 100 yards of advance under relentless M1 fire. Around him lay dozens of soldiers similarly overwhelmed, most with nearly full magazines, cut down before they could mount an effective response. The confrontation between the M1 Garand and Arisaka rifles reflects a broader truth of the Pacific War. Individual bravery, discipline, and warrior ethos were insufficient when faced with vastly superior firepower. By the end of hostilities, the United States had produced approximately 5.44 million M1 Garands, ensuring virtually every American infantryman wielded semi-automatic firepower. Japan, despite manufacturing over 6.5 million rifles, remained constrained by bolt-action mechanisms, unable to match the volume of aimed fire Americans could deliver. General George S. Patton's assessment of the M1 as the greatest infantry weapon of the war is not mere hyperbole. It is a conclusion supported by arithmetic and battlefield experience. From the humid jungles of Guadalcanal, where Army troops first demonstrated the rifle's superiority, to the volcanic terrain of Iwo Jima, where Marines leveraged it to reduce fortified Japanese positions, the M1 proved more than a rifle. It was a force multiplier. In the torrential rains of Cape Gloucester, through mud, volcanic ash, and chaotic battlefield conditions, the rifle's reliability never faltered. Its distinctive clip ejection ping became a symbol of American dominance, signaling that 8 enemy combatants were neutralized, a Japanese position suppressed, and another island secured. The Arisaka, though mechanically excellent and accurate at range, was fundamentally a weapon of the past. Against the semi-automatic M1, its bolt-action operation left soldiers vulnerable and limited their capacity to respond effectively in the intense and close-quarters conditions of Pacific combat. Across the campaign, the arithmetic of firepower repeatedly dictated outcomes. Rate of fire multiplied by accuracy equaled survival. And here, the Garand was unmatched. Today, Arisaka rifles are preserved in museums and private collections, prized for their historical significance and craftsmanship. The M1 Garand, likewise, survives as both a collectible and a functional firearm, still capable of remarkable precision at modern ranges. Yet during the Pacific War, one rifle clearly dominated the battlefield. Each American soldier armed with an M1 became effectively a mobile base of fire, an advantage that scaled across squads, companies, and entire campaigns. Across countless engagements, from the dense jungles of Guadalcanal to the volcanic islands of the Central Pacific, the rifle's semi-automatic operation turned individual soldiers into decisive instruments of war, demonstrating that the final arbiter in modern combat is often not courage or tradition, but industrialized, mechanically sustained firepower. 8 rounds, 1 pull of the trigger at a time, followed by the distinctive ping signaling a reload. This simple cycle embodied the lethal combination of engineering, training, and industrial output that underpinned American victory in the Pacific. The M1 Garand did not merely participate in the war, it helped determine its outcome.